Hello everyone, today I want to go over the question, what is amphiprotic? So amphiprotic is a term that you can hear thrown around a lot in general chemistry, and so I wanted to make a video and address it and show you actual examples of what amphiprotic is. So what is amphiprotic? So amphiprotic is a substance that can act as an acid and a base. And a common example you will see is water. But really quickly, let's go over the Bronsted-Lowry definition of acid and bases, because that's what I'm going to be applying in these examples. So a Bronsted-Lowry base is a proton acceptor. A proton, for those of you that don't know what a proton is a hydrogen plus, or you can see it written as H plus. A Bronsted-Lowry acid is a proton donor, so it gives a proton, it gives an H plus or a hydrogen plus. Okay. With that out of the way, let's go into these examples. So in the first examples, you see NH3 plus water equals NH4 plus OH minus. So ammonia, which is NH3, gains a hydrogen and becomes NH4 plus. Okay. So the way I like to approach things is I like to see which two pairs are like the most similar to see what's going on in the actual reaction. So when I compare ammonia and ammonium, I see that ammonia is NH3 and it gains a hydrogen to become NH4 plus or ammonium. Now, since it's gaining a hydrogen, it's accepting a proton, it's accepting a hydrogen plus, it is a Bronsted-Lowry base. So NH3 is a Bronsted-Lowry base. Water, on the other hand, looks closely to OH minus or hydroxide. So the water looks most similar to hydroxide. What's happened? Well, the water lost a hydrogen to become hydroxide. It lost a proton. So water is a proton donor. Again, it's going to be a Bronsted-Lowry acid. So again, the hydroxide would be the conjugate base, and ammonium would be the conjugate acid of NH3, which is ammonia. Now, for the next example, I have acetic acid and water, and then I have hydronium and CH3COO minus. Okay, so CH3COOH or acetic acid looks closest to CH3COO minus. And what happens between those two? Well, the acetic acid loses a hydrogen. Again, acetic acid. So it's a Bronsted-Lowry acid and it's a proton donor. It's giving away that H, the hydrogen, and it's losing an H plus. Okay, but who's gaining that H plus? Water is gaining that H plus and becomes hydronium. So if you look between water and hydronium, again, hydronium is H3O plus. The difference between water and hydronium is a proton, right? Water gaining a proton will become hydronium. So water is a Bronsted-Lowry base because it's accepting a proton. So again, this acetic acid is a Bronsted-Lowry acid. The conjugate base is CH3COO minus. Water is the Bronsted-Lowry base. And hydronium is the conjugate acid of water. Again, if you like this video, please follow, like, share, comment, and let me know if you have any other questions in general, and thanks again for watching.